I guess I'll start by just saying thank you to everybody for joining. We're really happy to have you here for this webinar on Intro to Airflow. Housekeeping things before we get started. This is being recorded and we will send it out afterwards. Feel free to throw questions in the chat. We will have time for Q&A after the presentation that I run through, but Barrage and maybe others can also help answer kind of as we go along. So feel free to throw things there. I guess I should have actually started by introducing myself before I did the housekeeping. I'm Kenton Danis. I'm a field engineer at Astronomer. I've had a lot of experience in data engineering and helping companies adopt Airflow. And one of my favorite things to do is talk about Airflow to people who don't know about it and haven't used it before. So really excited to do this webinar here.
Awesome. And I'm Barrage Pratt. I'm the field CTO here. I'll be helping out kind of policing the questions and making sure that Kenton has everything she needs over Zoom to crush the webinar, because this is her show entirely. Yeah, super thankful for everyone for joining. We've been doing these just about every 2 weeks. And I think something we've decided on is probably every month and a half or so, we'll probably do an intro session just to make sure that as we cover advanced topics, we are helping out people that are just getting started and just on the early stages of their Airflow journey. So I believe this is the first Intro to Airflow one we're doing, but we should be doing another one in probably another month or month and a half, depending on what you all ask for.
Awesome. So with that, I will jump right in. Over here. So I'm going to start webinar by going through a couple slides that cover sort of the concepts of Airflow, help talk about what it is and all of the terms, get everybody oriented for the discussion. And then from there, we'll hop into a demo and actually show some example pipelines and kind of how Airflow is used and how you can interact with it. So, but to start, I started talking about the agenda, but here it is. So we'll cover kind of what Airflow is, in case you're not aware, core components and concepts, sort of the benefits of running your pipelines as code. And then I'll talk about how to get Airflow up and running, or at least one method of doing so. And then, like I said, go through some demo DAGs. And then we will leave time at the end for Q&A. All right, so to start with just a little bit of background on Airflow, it was originally born inside of Airbnb. It's obviously since been open sourced and is now a top-level Apache Software Foundation project. It has a really robust and active community. It's one of the things that makes Airflow such a great open source tool. And at Astronomer, we're obviously heavily invested in open source Airflow, so we truly believe it's the de facto standard for data orchestration. So to get started with a definition, what is Airflow? It is simply a way to programmatically author, schedule, and monitor your data pipelines. You'll hear me come back to this term programmatically a lot. That is one of the key sort of core tenets of Airflow, is that everything is written in code. There are lots of benefits to using Airflow, but a couple that we like to kind of highlight here are that it's dynamic. So again, I'm already going to come back to this programmatic piece. Everything in Airflow is written in Python code, which means you have kind of the power of Python behind you. So it's really dynamic. There's really no limit to what you can do with it. Second is that it's extensible. So we'll talk a lot here about the ways Airflow interacts with other systems, but there are a lot of connections available out of the box for Airflow to talk to any number of different tools. But if there isn't one that you need already pre-built, it's also easy to create your own. So highly extensible there. And finally, it's infinitely scalable. So you have a lot of flexibility in how you set up your Airflow infrastructure. At Astronomer, we have customers that are running thousands of tasks every day on Airflow and can manage that all easily. So lots of benefit there from anything if you have, a very small environment with just a couple of pipelines all the way up to thousands and thousands of tasks running every day. Airflow can deal with all of that. So here I'll go through some of the core components of Airflow. I won't go through them in too much depth for this conversation in terms of kind of the technical background behind them, but I think they're really good things to know. If you are running Airflow yourself, you will certainly run into these terms and have to deal with them to some extent, and they're just generally good background to have. So the three kind of core components that are needed to run Airflow are the web server, the scheduler, and the metastore. So your web server is a Flash server, and that's going to provide you with your UI. So we'll look at that later. Your scheduler is the daemon that's responsible for scheduling your jobs. And then the metastore is your database and the backend where all of the metadata are stored. So those are the three really important components. You absolutely have to have those for Airflow to work and to run. A couple of other components that aren't necessarily the three core ones that I talked about there, but I think are still sort of fall into this category a little bit and are helpful to touch on are the executor. So this is going to define how your tasks get executed. And then you will likely have workers. So these might be processes that are executing your tasks as defined by the executor. So again, how you set this up in your own infrastructure, there's many different ways that you can do that, but these are kind of the core components that you're dealing with.
Hey, Kenton, I know a question we get all the time is around the metastore. Like what would you recommend using as the metastore for Airflow if you're getting started?
Yeah, so you have a couple of options. The three database engines that are supported by Airflow are Postgres, MySQL, and SQLite. I would say by far, as I'm aware, the most commonly used is Postgres, and it's probably the easiest to implement, especially if you're using like a cloud database. So that was, if you aren't coming in with any opinion on what you're going to use for your team or your organization, I would recommend using Postgres.
Perfect.
Yeah, that's a great question. So diving deeper into one of those core concepts, I want to talk briefly about executors, because again, this is something that if you are going to run Airflow, you will have to make the choice of which executor you're going to use. You have a couple of options available to you. Which one you use kind of depends on what you're trying to do with Airflow. And, we could spend a whole webinar talking about just executors, so I won't go into too much depth, but in general, the three main ones that you have available to you are the local, the Celery, and the Kubernetes. Local is going to mean that everything is going to run with your scheduler. So it's great for local development and development environments, but it does offer some degree of parallelism, but it's obviously not as scalable. The other two, Celery and Kubernetes, are both meant to scale. So they're going to require their own infrastructure. They're both sort of good in different scenarios. Celery is really good if you have a very high volume of short running tasks. Kubernetes gives you a lot of power in terms of auto scaling and task level configuration. So again, we could talk about this all day and I won't bore you with that, but these are, considerations when you're deciding how to run Airflow, which is going to work best for your use case. I added a little note about there technically is a fourth executor, the sequential one. I would not recommend using it. It doesn't offer any parallelism, so typically we don't see that one used in practice. And then, so diving into actually the core concepts of Airflow. So these are now going to be more related to kind of your pipelines and on the data engineering side, as opposed to the infrastructure that we just talked about. And within that, the most kind of high level concept within Airflow is a DAG. So DAGs stands for Directed Acyclic Graph. You can think about that as each node in that graph is a task, and each edge in that graph is a dependency. So a DAG is simply your data pipeline. They're defined as Python code, and the only rules for them are that your tasks flow in one direction and don't have any loops. So that's the directed acyclic part. So this is an example of a super simple valid DAG with a couple of dependencies between tasks. Something like this, on the other hand, would be invalid because you have that loop between T1 and T4. Doing something like this can create an infinite loop in your code, which is obviously bad. So that's not allowed. But past that, you can define your DAGs in whatever way you need to. Diving in a level deeper, you have operators. So operators are kind of like the building blocks of DAGs. So you can think of them as like a wrapper around each task that is going to define kind of how that task is going to get run and abstract away a lot of the code that you would otherwise have to write yourself. There are a couple of main types of operators in Airflow. First is action operators. So these are going to complete an action of some sort. So they're like the Python operator, which will execute a Python function, or the bash operator, which will execute a bash script, things like that. There are also transfer operators. So those are going to move data from one place to another. So you might have like an S3 to Snowflake transfer operator. So again, that's going to be an operator that's fully built out to make that transfer automatically, and you just input some configuration as opposed to you having to write all the Python code to do that. And finally, sensor operators will wait for something to happen. So they give you the ability to make your DAGs a little more event-driven as opposed to scheduled. So they might wait for a file to be dropped in a certain location, or for another DAG to be triggered, something like that. And then the next concept we talked a little bit about already is your task. So this is just an instance of an operator. So every time you have an operator that you are defining, you're defining that again as a wrapper around that task. And then your task instance is going to be a specific run of that task. So you can think of that as you have a DAG, and then you have a task within that DAG, and then for one run at a point in time, you have that task instance. Putting that all together, what that looks like. So again, for a full workflow, you have your DAG is your most high level concept. That's your pipeline. Within that, you can define your operators. They're a wrapper around each task, and then you can define your dependencies. Again, this is super flexible, so you can define those operators and tasks and dependencies to be whatever you need them to for your use case. Kind of to highlight that concept a little bit, I like to show this slide just to kind of highlight the, again, flexibility and power of writing your pipelines as code. It allows you to take, something like this, where you have a pretty complex network of interacting systems that have dependencies, and you can implement all of this while writing very little code using Airflow. Once a new requirement comes up for your business, you can integrate that easily, again, just by adding another operator. We'll talk a little bit about providers as well as we go, which are going to be, the kind of packages for each of these external systems, be that Snowflake or AWS or Databricks and things like that. But just note that all of these tools that are shown here have built-in Airflow integrations already. So again, that's part of the benefit of having the community be as robust and active as Airflow's is lots of people have done all of this work already. And so when you're implementing it, then you don't have to. So from there, I will hop over into a demo and sort of look at some of these concepts in practice. And to start off, I'm going to pop over to a terminal here, and I'm going to talk a little bit about getting Airflow up and running. So there are many ways that you can do this. Again, Airflow is open source. There are lots of tools out there for how you can run Airflow either locally or in production, and how you can get started with it. Probably one of the most common in general ways of running Airflow is using Docker to do so. That's how we run Airflow at Astronomer. There are lots of open source packages available to help you run Airflow with Docker. We also have the Astronomer CLI. So this is how I'm going to get started with Airflow. It's in my obviously non-biased opinion, one of the easiest ways. So our CLI is open source. It's available for anybody to use. Yeah.
Quick request from the chat. Could you just make the text on your screen a little bigger? So it's a little easier to read for some of these folks. Perfect. Yeah. Sorry, I didn't mean to cut you off, but
no problem.
For people to see that.
Yeah, thanks for letting me know. It's a good reminder. Yeah, so the Astronomer CLI, open source. It's available to for anybody to use. It's a really easy way to get up and running with Airflow without too much hassle. So you can just start playing around with it. Once you've installed the CLI, you can initialize an Airflow project by running this astrodev init command. I've already run that in this directory. What that's going to do is create a Docker file and then a set of files and folders needed for me to run Airflow locally in a Dockerized setup. Once I've done that, I can do astrodev start. I've actually already done that here as well. So if I do a Docker PS, you can see I have 3 containers up and running that were spun up by that command using Docker Compose. I have one, it's a little hard to see in here, but I have one for my scheduler, one for my web server, and you can see the scheduler web, it's a little wrapped here, but web server, scheduler, and then my Postgres database. So those are the 3 components that we talked about before. I now have those up and running. Before I hop over and sort of show the Airflow UI, I'll just highlight kind of the file structure for this particular project. The biggest thing here that I want to note is this DAGs folder. So that's where all of my DAGs or data pipelines are going to go. So the typical way of doing this is defining each one in a Python file. I currently have 2 here. In order for a DAG to be defined in Airflow, you have to have Python that is in this DAGs folder that then defines your DAG. So you can do this in a static or dynamic way. And we'll go through these DAGs in just a minute, but that's how those are going to get picked up by Airflow, is by having code that defines that DAG in this folder. So if I hop back over to, well, actually just to highlight, for my web server, you can see that I have this container running directed to port 8080. If I hop back over to my browser here and navigate to my localhost 8080, you can see I have Airflow up and running. So this took me to the Airflow homepage. I'll walk through the UI a little bit, kind of what we're looking at here before we hop into these 2 DAGs specifically. So homepage is going to show me, again, a list of all of my DAGs. I have various filters that I can use, and I can also trigger or even delete DAGs directly from here. Other useful views, if I click into one of these DAGs, like this example, common ones used here are this tree view, which is going to show me a sort of tree view of all of my tasks and dependencies. And I haven't run this one, but if I hop into this other one, it will also show me a list of recent runs and the statuses of all of the tasks and the DAG. So obviously these are color coded based on the status, whether they were successful or failed, whether they got skipped because of some upstream failure, something like that. So that's a really useful way of seeing sort of what is going on with your DAGs in the recent runs. If I go back to this other one, another useful view is the graph view. So this is going to show me a graphical view of how my tasks are laid out. So again, this one I have a bunch of different tasks and some with dependencies. So you can look at that there. If I were to turn this on, So you have to have the DAG turned on in order for it to run. This is a common mistake that I make myself all the time, is I trigger my DAG and go, why isn't it running? If it's not unpaused, it won't run. But I also turn on this auto refresh and go ahead and refresh this. And then if I trigger this DAG, I can run it here. I can see the status here, but I can also watch it in this graph view. You can see, oh, that one. Airflow 2.0 is really fast. So for this particular example, it's not that exciting to watch it go through. You just watched all those flash screens, but there, that one just turned. So this is another way you can kind of watch as they're running as well. Other useful views, I have this Gantt view available to me. So this is going to provide an overview of the duration of all of the tasks in my DAG. This can be really helpful if you are debugging, trying to figure out, what is taking longest, any sort of optimization that you're doing. That's a helpful place to start for that. And then finally, I'm going to hop into this code view at this DAG. So I showed you I had those 2 Python files in my DAGs folder in my code editor that we looked at. Obviously, this is one of them. I can also look at the code here in the UI, which is kind of helpful, especially if people might not have access to the source code, but they want to understand like what's going on in the DAG. You can see the code here. I'll kind of walk through what this looks like for this example one. And this one's pretty straightforward. It's just kind of the dummy example. So again, I'm using those action operators that I talked about before, the bash operator and the Python operator. Define my function that's going to get called for the Python operator. Here I set any default arguments related to this DAG. So with Airflow, you can set kind of configuration like this at the task level. So for each operator that you're instantiating, or you can also define default arguments that will be applied to every task in your DAG. So it's just going to save you from having to specify this every time if you have things that you're setting kind of globally at your overall DAG level. Some of the things in here are based on email alerting. So if I want to send an email if a task fails or has a retry, how many retries I want. So again, just error handling. So do I want the task to retry? How long do I want it to wait before it does? This is just kind of scratching the surface of how you can configure these things within Airflow. You have a lot of flexibility over what you do if something goes wrong. But this is kind of a simple starting place that people can use. From there, I go ahead and define the DAG itself. So this is the part that Airflow is going to pick up and know that I'm creating a new DAG here. So I give it a name. Again, some more parameters. So the start date, the schedule interval, so how often I want it to run. I'm passing in the default arguments, whether or not I want it to catch up. So if I had set this to true and turn it on and the start date was passed, Airflow will fill in all of the missed runs if there are any. And from there, I define all of my tasks. So I have my dummy operator that was that little start that you saw all the way to the left. And then I have a couple of bash operators we saw. So for those, I'm just giving it a task ID, passing in a bash command for this one. Down here, I'm creating those Python operators. And so this is a good example to show that you can dynamically create your tasks in Airflow, so they don't necessarily need to be static with a code block for every single one. In fact, if you have a lot of similar tasks where you might have, a different function, Python function for each one or something like that, we would recommend setting it up in this way, just because your code is a lot cleaner. It's easier to update. So this is going to loop through and create multiple different Python operators with different task IDs, and then obviously we're calling that function that we just looked at up above. And then finally down here, I'm setting the dependencies. So there are multiple ways to set task dependencies in Airflow. This is probably my preferred way. But you can also use, there's a set upstream and set downstream functions. So multiple options for you available there. But again, kind of core concept here is that, again, my entire pipeline is defined in Python code here. And like I said, this results in a DAG that looks like this. So that was kind of a simple example. From there, I want to pop over and look at one that's maybe a little bit more interesting, not just kind of dummy Python operators and bash operators. So for that, I have this other DAG in here called ADF Great Expectations. And what I want to highlight with this one is that, again, with that slide that I showed with all of the external systems like Databricks and AWS, like that, Airflow has these built-in hooks and operators available to interact with all of these systems all ready to go. So if you are, a data engineer or data scientist and you haven't been using Airflow, but you're already working with obviously a set of tools, it's very likely that Airflow can easily integrate with them. Astronomer, we like to talk about how, it's typically Airflow and some other tools. So it's, this is what Airflow is built to do, is be an orchestrator that talks to other systems. It's, I think, as far as I'm concerned, rare to see people that, are justifying, like writing their own Python code for DAGs. So want to show an example of that in practice here. Raj, were you going to say something? Like
no, I'm just excited to see the code view.
Okay. Before, I'm going to make you wait one more minute. Before I pop into the code view for this DAG, just to kind of talk about that point in a little more, I do want to make a plug for Astronomer registry, just as a great place to go if you're getting started with Airflow to kind of discover all of these things. So this is a way to look at, again, those provider packages. So that's, packages that are used to integrate Airflow with external systems. So for Azure, I can come here and see like the operators and things that are available to me. So if you're just getting started and you want to know what's out there, this is a great place to start, just to kind of discover all of that. So now I'll hop over here into the code for this one. So what I wanted to show from this DAG is a use case of Airflow interacting with a couple of common tools. So ADF in this case is short for Azure Data Factory. So that is a, kind of similar to a pipeline tool in itself. It's one we oftentimes see used in conjunction with Airflow because you can kind of get the best of both worlds in that way. And then Great Expectations is another kind of open source tool for running checks and kind of quality control per se in a Pythonic way on your data. So it's something we oftentimes see, analysts, data engineers, data scientists using. For both of these, what I'm going to show here is that there's a really, really easy way of integrating them both with Airflow, which is super nice. So again, I'm going to start with, actually, I should show you the graph view first so we know what we're looking at. I'm just pleasing Barrage here. So what this DAG is going to do is it's going to, again, using kind of built-in, ready to go hooks and operators, it's going to trigger a remote Azure Data Factory pipeline. That pipeline is going to generate some data. I'm then going to download that data, run a Great Expectations checkpoint on it to check quality. And then at the end, if everything's all good, I'm going to send an email that says, hey, this data is all good. So pretty straightforward. If I look at the actual code for this, again, the important parts here are I'm importing this Azure Data Factory hook, this WASP hook, which is what is used to interact with Azure Blob Storage. So that's where my Azure Data Factory pipeline stores the data that it generates. And then the Great Expectations operator. So again, another different provider package there. At the top here, I define the date that I'm going to use that I'm grabbing the data for. So I have it set to grab yesterday's data. Just a note sort of on general Airflow best practice. If you can, it's really good to use Airflow built-in variables or macros like this one. So this is going to help make my DAG item potent by pulling the yesterday's date based on my DAG execution time, as opposed to me sort of hard coding the date or calculating it up here. I'm going to define some file paths that are used by Great Expectations. I then have a Python function that runs my Azure Data Factory pipeline. You can see there's not much code here because, again, I'm making use of this built-in Azure Data Factory hook. I then have another one that makes use of that WASP hook to download the data. So again, just simple 2 lines there. Define my default arguments, and then down here I'm going to define my tasks. So I have my first 2 Python operators that run the pipeline, download the data. Then I run my Great Expectations check. So for that, I'm using the Great Expectations operator. I pass it in the data that I want to call that check on, as well as a Great Expectations suite. So this is a supporting file that tells Great Expectations what checks I want to run on the data. And then finally, I'm using the email operator to send an email. So I'm passing in saying the Great Expectations check successfully. And finally, I define my task dependencies there. So if I go back to the graph view and trigger this, this one will actually take a second, so it's a little more interesting to watch as it goes through. But fun feature in Airflow 2.0 is that auto refresh. So we can see it's run the pipeline, it's downloaded the data, just finished the Great Expectations checkpoint, which passed, and then it sent me an email. This is really useful. So for these data checks, things like that, and defining the dependencies, if this Great Expectations checkpoint had failed, so there was something wrong with the data, it didn't pass the test, it would not have sent me the email. So if I look at the tree view and sort of some past runs, you can see there's this string here where this Great Expectations check was failing, and those are red. And then you can see the send email ones are all orange, which means upstream failed, so they were not run. So I can sort of build in some controls around, okay, if this sort of thing happens, I don't want to move on to anything downstream.
Then can I alert on those failures? So we have the successful email sent, but can I do one if it fails, or maybe if the next task doesn't run? As a question from the chat.
Yes, absolutely. So one, probably the lowest hanging fruit way of doing that is turning on these email on failure and email on retries. It means Airflow is going to just send you an email. You do have to configure SMTP in your Airflow environment, but as long as it is configured, if you have these turned on, Airflow will send you an email saying, hey, this task failed. And it will include a link to the logs and things like that. You can set these at the DAG level. You can also set them for specific tasks. And you can get much more kind of fancy if you want to. So you can set up Slack alerting. That's something I've seen folks do a lot. You can define, functions that get called if you have a failure. And so you can kind of define in that function whatever you want to do. But yes, there are lots of built-in alerting possibilities. Great question. The other thing I want to highlight kind of with the tree view and some of these failures is the logs in Airflow. So if I came in here, say I got an email that said, hey, one of your tasks failed and I want to figure out what's going on, I can come in here and click on that task and I put this log available here. So this is going to give me a log from the task, and I can come in and see what went wrong. So here's my error down here for this one that I have since fixed. But you have all of that kind of at your fingertips in the UI here. One other kind of Airflow key piece that I will highlight if I pop back to this code, this pipeline, is you'll notice, so in this case, I'm interacting with a couple of external systems, this Azure Data Factory, this Azure Blob Storage. So kind of a natural question is, how am I actually getting Airflow to talk to those systems? You can see in the code here, here's an example that I'm passing in this Azure Data Factory con parameter. For this WASPhook, I'm passing in an Azure Blob connection ID. So anytime that you are using an Airflow hook or an operator that is talking to some external system, you will have to define a connection that Airflow will use to talk to that system. One easy way of doing that is coming up here and going to admin and then connections. And here you can see those two that I just mentioned where I've defined. So this is where I have given the credentials to connect to my Azure Data Factory instance. All connections work a little bit differently. So what you put in these kind of depends on which system you're talking to. The nice thing is, so any passwords are going to be encrypted. So there actually is a password here. You just can't see it because Airflow blanks that out for extra security. I go back. So I've defined those there and would have to do so for any other hook. You don't necessarily have to define them in the manually create them in the UI like this, but if you're just getting started, this is a good place to start, is to come in here, find the connection type that you're looking to use, and then go ahead and define how you're going to talk to that system, your credentials.
Where else could I define those credentials if I'm not going to put them in the UI here?
Yeah, so you can set up a secrets backend is one common way of doing this. So lots of people like to do that because if you're running this, especially at scale, you might have like rotating passwords and access tokens, things like that. You don't want to come into your Airflow to change them in another place. So if you're using something like a Vault or AWS Secrets Manager, things like that, you can connect that to Airflow so that Airflow looks in that location for your secrets. There are also other ways you can do it depending on kind of the infrastructure that you have set up, but those are probably the two most common.
Awesome. So Kenton, we have about 21 questions in the chat here for you. So
that's great. Perfect timing. So I was just going to say that was what I wanted to show. So let's open it up in the last 15 minutes for questions. We'll try and get to as many of them as we can.
So it's like the lightning round or something here.
Yeah.
Alrighty. So I will just start as they came in here to make sure that we get to everyone. So, one question that is, I think we get a lot, right, is you had a couple of dummy operators in your DAG. Like what's a good time to use the dummy operator?
Yeah, I think usually just when you're trying to sort of organize things in a certain way is one. That's kind of this use case here, is it's just easiest to have sort of a start as opposed to having these floating, especially if you're defining them in a loop or something like that. The other way I've seen is I have occasionally wanted to use branching within my DAGs, which means I have, in some different paths that the DAG might take based on some external criteria. The branch operators that are available for you to use in Python require something to be downstream in both parts of the branch. So if you have a use case where I want to move forward if this condition is met, but do nothing if the condition is not met, one way of doing that is to have just a dummy operator on the other side of your branch, so that you just don't do anything. So basically, anytime you need sort of a task for some functional reason, you just don't want it to actually do anything, is a good way of using those.
Yeah, almost like an organizer.
Right.
Can you do dependencies between DAGs?
Yes, to some extent. So they're not sort of native in the way of like, I can't just define them like this in my code. But there are ways to make kind of different DAGs talk to each other. One way is the trigger, I think it's trigger DAG run operator, which is an operator that will trigger another DAG. So that's a good way of making two kind of dependent. Another way I've seen is using the API. So especially with Airflow 2.0, where there's a fully stable REST API, you can trigger a DAG via an API call. So that's another way you could do that with a HTTP operator within another DAG, depending on kind of what you need.
Yeah. And I think Mark even linked to a pull request coming soon in Airflow that'll let you visualize that in the UI a little better as well. So I'm pretty excited about that.
Exciting.
So this questions came up a few times. So, if I'm just looking to get started with Airflow, or I want just like an introductory, like 101, where's the best place to go?
So I would say if you're looking to get started just to get working with it, again, the Astronomer CLI is an easy way to get up and running locally if you just want to play around. If you're looking for more sort of in-depth instruction on how to use Airflow, I'm going to shamelessly plug Mark's course, because it's really in-depth. It's really easy to understand. This is, not actually kidding. It's how I learned Airflow like a couple of years ago, when I was first getting started as a data engineer. So covers all the core concepts. It goes through really great examples. Obviously, there are lots of great resources out there, but that's just the one that I personally am familiar with and really like.
Yeah, we'll send out a link to it afterwards. It's also available on academy.astronomer.io. Lots of great stuff there, and there's even a certification for you. So another question on some of the alerting, right? If you want to make it so that you want a notification if a task never starts. So, my first task runs and I want to know if my second task never starts. Are there ways to accomplish that inside of Airflow?
Yeah, that's an interesting question. I'm trying to think of the best way to do that. You can definitely build in alerting for just in general, like if your DAG doesn't finish, if certain timeouts occur, things like that. You can also, depending on kind of your infrastructure, sometimes folks will build alerts kind of based on, their scheduler health and things like that. But might not necessarily be like, oh, a specific task didn't run, but it would let you know if there was a problem with your scheduler. That's probably what's causing your task to not run. So that's kind of another thing that comes to mind that I see frequently.
Yeah, a lot of ways to approach that. What's another? So how do you handle transferring data between one operator to another?
That's a great question. And we have, I will reflect on a webinar that we've done in the past that you can find the link for, TestFlow API. But kind of the short answer is the built-in native way of doing that within Airflow is using XComms. So it stands for cross communication. It's a sort of messaging service so that you can pass information between your tasks. I will note that it is not designed to pass data, or at least large chunks of data between tasks, because it is making use of the Airflow metadata database on the back end. So you're writing information to the database and then pulling it from the next task. So depending on kind of what the data is that you're looking to pass in between, there are multiple ways of handling that. Again, we have I would reference, we can even find the link for it. We have a guide on Astronomer's guides website on passing data between tasks that talks about kind of different methods that you have of using that based on kind of the scale and things like that.
Yeah, that's such a great question. There's so many ways to think about that. We did a whole webinar on that topic. What about, another question from Purna here is, is there an API to get the status of my DAG runs and my task instances?
Yes. Yeah, so the again with Airflow 2.0, there's a fully stable REST API, and you can add, there are absolutely endpoints for getting task instance information, things like that. There's great documentation for the Airflow API on the Airflow website.
Yeah, the new Airflow API is great. Question around triggering DAGs. When you were triggering DAGs from the UI earlier, you saw that you could pass in like context for your trigger. Is it possible to trigger a DAG for a date in the past using that functionality?
Yeah, so there are a couple of ways that you can trigger a date. In fact, this is, let me go to this other DAG is a pretty good example of this, given that it actually is date parameterized. So obviously in this case, I'm using a built-in Airflow variable for yesterday's date. I don't have to, so I can define kind of my own variable here that I want to use and then pass that in at runtime. So that would be one way of doing something like that. You can also, Airflow has a lot of functionality around like backfilling. So if you have DAGs that are date parameterized and you want to run them for past dates, there are other options for doing that that don't require you to like manually pass in a date. But if you had just a specific date that you wanted to run for, that could also be an option.
So question from Saurav. I think what we showed so far was around using Airflow as a data orchestrator, kind of coordinating your pipelines. Could you use it to host kind of your heavy scalable machine learning pipelines as well?
So yes and no, depending on how I understand the question. So you can absolutely use Airflow to sort of orchestrate machine learning use cases. We see that all the time. What you don't want to do is use Airflow itself for kind of heavy duty data processing. So if you have really large data, you're going to want to offload that somewhere else because that's not what Airflow is built for. So if you have machine learning models where the training of the model is super computationally intensive because you have a lot of data, you're probably still going to want to do that in like a Spark or some kind of processing framework like that. And then where Airflow would come in is orchestrating all of that and managing failures and dependencies and things like that. Like I said, there are a lot of kind of built-in hooks and operators for the tools that are oftentimes used in machine learning use cases.
Yeah. So there are a couple of standard architectures that we've implemented with our customers in the past around that. If you're interested, please reach out to us and we'd be happy to talk you through it. Mark that question is done. Let's see what else do we got here. Is there an easy way to run Airflow on a Windows computer? Is the CLI also Windows compatible?
So the CLI is Windows compatible. In general, Airflow, somebody correct me if I'm wrong, because I'm saying this from my knowledge of 2 years ago when I tried to do it, but Airflow cannot, I think, be run locally just by itself on Windows. I think you can on Mac or Linux. However, like we talked about before, a very frequent way of running Airflow is using Docker, and so that you absolutely could do on Windows.
Yeah, I think the Windows story has gotten a lot better over time. I'm not sure what the most up-to-date one is, but like you said, the Docker runs really well on Airflow, and Airflow runs really well on Docker, and that's all you need. I think you might have answered this one, but just to make sure here, Jose is asking, can you have conditional branching within Airflow, within your DAGs?
Yes, absolutely. There are a couple of built-in operators to help manage that for you. One is the branch Python operator. which is going to basically, you pass it a function that determines some logic, and then you tell it which direction to take based on what is returned from that function. There's also a short circuit operator, which will basically like stop your pipeline at a particular point, so you can determine whether or not to move forward based on a condition. So those are two kind of really easy built-in ways to do that. But again, I have seen other sort of more creative ways too, just because everything is written in Python. You have a lot of flexibility there.
Question that I know you've thought about recently is, can you have DAGs that create new DAGs in Airflow?
That is a very timely question based on what I've spent the past couple of weeks doing. The answer is yes. You can dynamically create your DAGs. So again, kind of the core piece of Airflow is going to parse any code in the DAGs folder that has the word DAG or the word Airflow in it. If you have a script in that folder that then generates other DAGs, as opposed to defining the DAG itself, like I've showed here, Airflow will execute that code and generate the DAGs. So we have a guide on dynamically generating DAGs, and it's about to get a pretty big update with some other methods. It is something that we think about a lot. We get that question a lot. I would definitely recommend it because there are sort of some gotchas depending on your scale and kind of how you're doing that. But that was a long way of saying yes, you can have a DAG that creates other DAGs.
Yeah, I'm looking forward to that updated guide because I think that's one of our most highly viewed guides as well. So it'll be good to give that a refresh. Questions around this great expectations operator that you were using? Is that something that is specific to just Astronomer, or can I use it with open source Airflow as well?
No, you can absolutely use it with open source Airflow. Astronomer does not have any operators that are only available on Astronomer. The Great Expectations one is just a Python package that you can install. If you check it out on the registry, there's a great page for it here that kind of talks about how to use it. So.
Awesome. So we still have a ton of questions left here, but unfortunately we're just about at time because I do want to take the last 2 minutes to pub, and Kenton, I'm going to grab the screen from you for a second. But if this was interesting to you and you love Airflow, we encourage you to sign up for the Airflow Summit. It is 65 days away. There's going to be all sorts of talks across all sorts of use cases on here. We are very excited for it. And if you're interested in talking, please reach out to us. And yeah, we very much want you to attend. We'll have some more information on it coming in the next couple of weeks, but shameless plug for the Airflow Summit on July 8th here. Please sign up because we know there's some great stuff coming. So that said, I think we're ready to call this one done. Sorry for the folks whose questions we didn't answer. Please email us. You'll receive some contact info afterwards, and we'd be happy to answer them kind of offline there. But thanks to everyone for joining. We really appreciate you giving us some time of your day here.
Yeah, thank you everybody, and thanks for the great questions. We love to see this type of engagement out in the community. So we will definitely do more of these.
And look out for an announcement for the next topic, which we should be getting to you pretty soon here. Alrighty.